Let's graph this piecewise function. When we're graphing a piecewise function, we have to be aware of the different pieces of the domain. So over here on the right, we can see that the domain is broken up into 3 intervals. So that means that the function value depends on which interval we should be looking at. So the first part says that if x is less than -2, we have a certain value for the function, and that value is -4. So at -2, we're going to go down to -4. We're going to put a circle there, though, because at -2, we are not including the value of -2. It's less than -2. So to the left of -2, the function value is -4. So that means no matter where we are to the left of -2, the y values are all -4. Now, between -2 and 1, let me just mark -2 and 1 on here, we have the line x minus 1. So let's start graphing the line y equals x minus 1. The y-intercept is right there. The y-intercept is -1. If we were to plug in -2, -2 minus 1 is -3, so that's going to put us right here. If we were to plug in 1, that would be 0. And we're including the values at -2 and 1 because we have a less than or equal to in both positions. So now we connect the dots, and that's what the middle section looks like. Now if x is greater than 1, we have the parabola x squared. So if we plug in a 1, 1 comma 1, but we need to put an open circle there because we're not including that point. And then 2 comma 4, 3 comma 9, etc. We don't have to graph all those points, but we get the idea that that's a parabolic piece right there. Now one question that comes up frequently is the domain and range of this function. So this is a picture of the function. This is a picture of y equals f of x. It's a piecewise defined function. It's got these breaks or transitions, but it still has a domain and range. So let's calculate the domain and range for this function. The domain is a subset of the x-axis. When we're looking at the x-axis, are there any x's for which there is no y value? And the answer is no. There's no x's that are missing over here. We have all the x's to the left of -2, and then we include -2 up to 1, and then we include 1 all the way up to infinity. It may look like this doesn't go out to infinity, but it does. If we plug in x equals 5 million, the y value would be 5 million squared. So the domain is all real numbers. If you wrote it in interval notation, you would write it like this. Now the range is going to be a little harder to calculate. We have to look at a subset of the y-axis. We have to look for all the y values that the function has. Generally, we start from down here, -infinity on the y-axis. There's no y values on the function here, and then we bump up to -4. -4 is a y value, but it's a singleton value. It's not connected to any other values, right? It's isolated down here because there's no y values between -3 and -4. The y values pick up again at -3, so we're going to put a union, and then we include -3. And we have -3, -2, -1, all the way up to 0. And we're including all those values. And then the y values pick up again. Let's see, they pick up again at 1. And then go on forever up. But we are not including the 1. So we'll have a parenthesis on that. So that is our piecewise function with its domain and range.